Finishing up our conversation about the binomial theorem, I have one more interesting application to go over in detail. So here is the example. We want to prove that n times 2 to the n minus 1 is equal to the sum of k times n choose k. So I'm going to do this in two ways. We're going to do it algebraically using the binomial theorem, and we'll do it combinatorially by thinking about committees. Let's do the algebraic one first. So look at this statement and look at the binomial theorem. It often helps when you're trying to prove an identity with binomial coefficients. Just write down the binomial theorem and you might get inspiration. So when I'm looking here, I see an n has dropped from an exponent here and a k has dropped from an exponent there. And so that tells me that probably what's happened is it looks to me like I've done a differentiation. This is a polynomial after all, so you can differentiate it. I only see the x, the derivative with respect to x. It looks like y has kind of gone away. I don't see anything here that's got an exponent, so I think y has gone away. So I'm going to start by getting rid of y. So I'm going to set y equal to 1 in the binomial theorem. And what does that give me? That gives me x plus 1 to the n is equal to the sum from k greater than or equal to 0, n choose k, x to the k. That's a little simpler, and this is a way that we often like to write it. Okay, so now I'm going to differentiate with respect to x. So now I'm going to apply d dx. This we can always think of when we go into other things. We can think of it as a formal power series if we want, but in this case it's just a polynomial, so there's no problem with differentiating. X plus 1 to the n is fairly easy to differentiate. I get n x plus 1 to the n minus 1. So at this point, I knew I wanted to differentiate. I didn't see the y. I prefer one variable calculus, and that's why I've gone here. I'm going to reevaluate where I am and try to massage things a little more after this step. But for now, I'm just I had my first idea, get rid of y, differentiate, and I'm just going with it, and I'm going to see what happens. So we have k greater than or equal to 0. N choose k is just a number. K is just a number, right? It's like, this is like 6 if it's 4 and 2. So this is just n choose k, and I differentiate x to the k. I pull down the k, and I get x to the k minus 1. So that was pretty easy. I do need to be a little careful here. I have a k equals 0 here, and technically that would give me a 1 over x, and that's not going to be a derivative of anything, right? We did not get a derivative of 1 over x. I'm actually okay doing that and leaving this as 0 because there's a k here. I am actually multiplying it by 0 for that term, but if you want to be really precise, this should actually start at 1. And in fact, this one up here we can see can also start at k equal 1 because again, when k is 0, you've killed it. So you do need to be a little careful with your indexing there, but it's not too bad. Now let's compare. This is what we have, right? We started at the binomial theorem and we're trying to get to this blue statement. This is where we've gotten so far. What do we see? Well, we want to have a 2 to the n minus 1, so probably we should just set x equal to 1 now. Let's do that and see what happens. So the last step we're going to set x equal to 1. What happens? We get n times 2 to the n minus 1. That's good. That's what we wanted. Equals the sum k greater than or equal to 0 of k, n choose k, 1 to anything is 1, and that's the end of the proof. So that worked out pretty well. So when you see things down here, know that, okay, probably what's happened is we've probably done a derivative. Now let's talk about how we could do an algebraic proof of the same thing. A combinatorial proof of the same statement. So we have this statement, and I want to think about it in terms of a committee, right? I've got my n there as my pool of applicants. So I want a committee from n potential members. Oh, I don't know why I'm throwing in random extra letters here. From n potential members. That's my standard thing to have. But I've got this n floating out here, and I've got this k. That means I've chosen. So here, n choose k means there were k people on my committee, and I picked one of them. So I'm going to call that the president, or with a chairperson. So I'm going to choose a committee, and it's going to have a chairperson. So now I just have to figure out how to make each side of this expression match that. So first, I'm going to do the left-hand side. What's happening on the left-hand side? On the left-hand side, I have again, it's usually, when I'm doing this one, usually I go person by person. But here, because of the N, I want to make sure that I pick my chairperson first. So pick the chairperson in N ways, because I've got N total people, so I can pick one of them to be the chairperson. And now, then, I'm going to go with the rest of the committee. I'm going to go person by person and decide if they are on or off. Those are my two choices, if they're on or off the committee. That's how I think of the left-hand side as giving me an interpretation of this. So now, what about the right-hand side? How does the right-hand side count the same thing? So again, these problems all have the same flavor. If you do enough of them, you sort of start to pick it up. On the left side, I sort of just go person by person. And on this side, I usually think about the structure of my committee. So I'm going to choose a size of my committee. So choose a size, and this is what we're going to denote by K. Now here, there wasn't really a size 0, but let's go with it because, again, the algebra works out here. So we're going to choose the size, okay? And then we're going to do in choose K, and we're going to pick the people. So pick that many members in choose K ways. So here, choose a size means we're summing over K. We take in choose K ways. And now, anoint a chairperson in K ways. We now have a committee with K people on it. We choose which one will be the chairperson in K ways. So we can do it algebraically. It was a little harder to see the algebraic interpretation this time. We had to notice that different derivative. And we could also do it in terms of choosing the committee thing. So maybe I'll give you one more problem to think about on your own. Well, it's kind of an interesting one that goes with this idea. And you can try to think about it in terms of a chairperson and a committee, or you can think about it in terms of the binomial theorem. And here is the problem that I think is rather fascinating. Prove that 2 to the n minus 2 times n minus 1 is equal to the sum from k greater than or equal to 0 of k times k minus 1 times n choose k. You can see that what's happened here is I've differentiated twice. So if you want to apply the same technique that we have here of differentiation, on the other hand, if you'd like to apply this sort of argument to it, then what's happened is I've picked a president and a vice president. So you can test your understanding of this problem by working this example, which is just slightly more involved, and try it in both ways.